Welcome to the channel Physics by IITians. This is the third lecture of vector analysis. In this lecture, we shall learn about the integration of vectors. Okay, so integration means there are three types of integration in vectors. One is line integration, that is integration along a line. Another is the surface integration, that is integration along a surface. Another is a volume integration, that is integration along a volume. So we will learn the line integration, surface integration, volume integration related theorems, and we will solve some previous year NET, GATE, JAM, TIFR questions. And we will understand what is the physical meaning of these vectors also. So this video is very much important for you. If you are a physics student, you should know, you should understand mathematics, and you should relate physics with mathematics. So that's why this lecture is going to be very much important for you, for your preparation of examination, also for preparation of the interviews also. So I repeat that please watch the video carefully. So first we shall discuss about the line integration of vectors. So what is the line integration? So the line integration or integration of a vector, a curve, is known as the line integral. Okay, suppose we are taking a vector that is f, and which is dependent on x, y, z, that is dependent on the coordinate, three-dimensional coordinates. So it is a vector function and we are taking a curve AB. So what is the line integral of a vector function f along the curve AB? It is defined as the integral of the component of f along the tangent to the curve AB. So here you are taking a function vector f and you are taking a curve AB. So what is the line integral of f on AB? That is that component of f along the tangent of AB. Okay, and it is represented as integration over c f dot dr, or it can be represented as integration over c f dot dl, or it can be just represented as integration over f dot dl. Okay, so in physics, what is the meaning of this integration, that is line integration? So suppose f represent the variable force. The force can be mechanical, the force can be electrical, the force can be magnetic force. Okay, so suppose f represents the variable force acting on a particle that is along AB. Okay, so the total work done by that force is integration over a to b f dot dr. Suppose v represents the velocity of a liquid, then closed integral over c v dot dr is called the circulation of v round closed curve C, where closed integral means this is the closed curve. So whenever you are asking, or you are someone is asking you that if a force is applied on some particle, what will be the work done for that force, just you have to calculate the line integration along the path. Okay, suppose there is a liquid and liquid is have a curl motion. How do you represent in the integral form? You have to represent it with the closed integration over v dot dr. Why closed? Because the circle, or the path is closed, or the contour is closed. Okay, so the properties is, suppose a conservative field A. So the work done by a conservative field in moving a particle from P to Q is integration over P to Q f dot dr. So this can be written as integration over P to Q grad phi dot dr, because f equals to grad phi. Okay, and it can be written as integration over p to q d phi, where phi is the scalar potential. So it is phi q phi at point q minus phi at point p, that should be independent of path. Okay, so the conservative field, the work done should be independent of the choice of path, whether it is going through this way from p to q, whether it is going through this way, or whether it is going through this way. The work done is independent of path. It is only depending on the final potential minus initial potential. Now the closed integral for the work done, that is work done by a conservative field A in moving a particle around a closed path, that should be phi p minus phi p, or phi q minus phi q, because it is coming back to its previous position or initial position, that should be equals to 0. So this is an important concept, that for the conservative field, the work done is moving along a closed path, that is C. Okay, so suppose I am taking an example that you are given a force field F, that is 5xy minus 6x square I cap plus 2y minus 4x j cap, and evaluate the line integral, that is closed integral over C F dot dr along the curve C in the xy plane given by y equals to x cube from the point 1 1 to 2 8. Okay, so what you have to done here, you have to do closed integral over C F dot dr, and where F is given. First you have to find out F dot dr, then you take the closed integral, and don't worry about the vectors, because whenever you are performing the dot product, that is F dot dr, this quantity is scalar quantity. So scalar quantity means just numbers, and with numbers you are easy for the integration, the simple integration you have to do. Okay, so first work is we have to find out F dot dr. So here F is given as 5x to the power 4 minus 6x square I cap plus 2x cube minus 4x j cap. So now F has been written. Now F dot dr. So dr you can write as dx into I cap plus dy into j cap, because r equals to x I cap plus y j cap. So dr will be dx I cap plus dy j cap. So here dx into I cap, in place of y you can write as 3x square. Y is dy equals to 3x square because y equals to x cube. So r equals to x I cap plus 3 x cube into y cap j cap. Okay, so dr equals to dx into I cap plus 3x square into j cap. So this will be dr. Okay, so here look here, r equals to x I cap plus x cube j cap, because in place of y you write it as x cube, and dr becomes dr I cap plus 3x square dx j cap. So put it, that is f dot dr becomes if integration over that contour 5x to the power 4 minus 6x square I cap plus 2x cube minus 4x j cap dot dx I cap plus 3x square dx j cap. So I dot I here, that will give you 5x to the power 4 minus 6x square dx plus 2x cube minus 4x square into 3x square. Just simplify this in multiplication, you will get the value as 35. That's all. And here the integration limit is from 1 to 2, because you are taking the integration with respect to dx. So the change in x, that is 1 to 2. That's all. So you don't have to find out the dy, because you are writing y in terms of x. So friend, here this is the traditional way of finding out the line integral. Okay, suppose I am taking another example. Suppose look here, this one example I am taking. Here from O to A we can have different choices of paths, like I can go O to A directly by this way, or I can go O to A by this path, or I can go O to A by O to B then B to A. So I will find out what will be the work done over the three paths. So the three paths, first one is we are taking the parabola, that is y equals to x square. So what will be the integration, that is integration over C f dot dr. So it will give you, f is given as y I cap minus x j cap. So here it is a minus sign. So y I cap minus x j cap dot dr means dx I cap plus dy j cap. So simplify it, it will give you y dx minus x dy. So first take the parabola. So parabola, that is y equals to x square, it is given, and this is the point of xy as 0 0 to point xy at 1 1. So from y equals to x square from 0 0 to 1 1. So dy is 2x into dx, because y equals to x square. Okay, so and x varies from 0 to 1. So integration over C f dot dr is integration over 0 to 1. 1 is the x square dx minus x into 2x dx, because in place of y you write x square, in place of x you write x, in place of dy you write 2x into dx. That's all. So x into 2x dx. So simplify it, just simple simplification, it will give you the result minus 1/3. Suppose I am taking the second path, that is from O to B, then B to A. What will happen here? You have to note here the two different paths. Where one path, that is along O to B, y is 0, so dy will be 0, but the change in x is from 0 to 1. Okay, and along B to A, x is 1, but change is x is 0, because there is no change, but y is changing from 0 to 1. So here for the first path you have to take the change in dx, and for the second path you have to take the change in y or dy. So what will happen to f dot dr? So for the first path, dy term will not be present. For the second term in this path, in the second path, the this dx term will not be present. That's all. So here in place of y you write the value of y. Here the value of y is 0, so it will be 0 dx, and in for the second the value of x you write 1, because this path here x is 1, so you write integration 0 to 1 minus 1 di. So one is calculating the change for this path, another is calculating the change for this path. The two integration, just solve it, you will get the result minus 1. Okay. Now I shall take the third path, that is from O to A with the straight line. So first you find out the equation of the straight line. Here the coordinates are 0, 0. Here the coordinate is 1, 1. So what will be the equation of the straight line? That is y minus 0, that is y minus y naught, equals to x1 minus x naught by y1 minus y naught into x minus x naught. So 1 minus 0 minus divided by 1 minus 0 into x minus 0. So y equals to x. So it will give you the equation of this line. Now dy equals to dx here, because y equals to x. So f dot dr, the change in x will be 0 to 1, because from 0 x is changing 1, and we can write dy as dx and y as x. So just put here x into dx minus y into x into dy. Here it will be x into dx, because dy is also equals to dx, so it will give you 0. So here what you understand, the work done is path dependent, because choosing different paths it is giving you different result. One is minus 1/3, another is the first one, the minus 1/3, another is giving you minus 1, and the third one is giving you 0. So which one is the minimum path? This one, that is 0.33. Okay, minus 0.33 and minus 1. So which one is greater? You just comment the answer. Okay, that which path is the smallest path. This is the quiz question. Suppose the question may be framed that you are given three different paths. Okay, which path is the least path? Then you have to also do this. So this is your quiz question. Please answer to the comment section. So understand please here that this force is not a conservative force. Also you can be asked that is the field is a conservative field or not. Then there is a simple process of finding out the conservative field. You just find out the curl. I will tell you, because you don't have to find out the integration there. Just if it is a closed integration, we can apply Stokes theorem. Let me come to that portion. So this is the surface integration of vector. The surface integration of vector is denoted by surface integral over s a dot n cap ds, where n cap is the direction of the surface. Now how do you understand what will be the direction of the surface? Because surface is a two-dimensional one along, so you have to take two segments. Okay, so suppose the surface within xy plane, so the direction of the surface will be along z cap. Okay, suppose the surface within yz plane, the direction of the surface will be along x cap. Suppose the surface is along zx plane, the direction of the surface will be along y cap. This is the simplest thing that you can understand here. The perpendicular direction represent the direction of the surface. Okay, or the perpendicular to the plane, you take the direction perpendicular to the plane, it will give you the direction of the surface. And what will be the volume integration? The representation of volume integration, that is integration over V over the volume integral A dot dV, where dV is dx into dy into dz is the infinitesimal elementary volume of the system. So suppose I am taking here some, first we should know some theorems that are very much important. First one is the divergence theorem, second one is the Stokes theorem. What is divergence theorem? The divergence theorem is applied to convert the volume integral over the surface integral or the surface integral over the volume integral, and the Stokes theorem is applied to convert the line integral to the surface integral or the surface integral to the line integral. But most important part here, the divergence theorem is the surface is closed, and for the Stokes theorem the line is closed. So what is the statement of divergence theorem? The statement is, if V is volume bounded by a closed surface S and A is the vector function of a position with continuous derivatives, then volume integral over V del dot A dV equals to closed surface integral over S A dot ds. Okay, or A dot n cap ds. So the volume integral over a vector field over volume V is equals to closed surface integral over a surface. And the Stokes theorem is, if S is an open two-sided surface bounded by a closed non-intersecting curve C and A is a vector function of position with continuous derivatives, then closed line integral over C A dot dl equals to surface integral over curl of A dot n cap ds or surface integral over curl of A dot ds. So if S is the open surface but it is closed, sorry, F is an open two-sided surface bounded by a closed contour or closed curve, then if you take the line integral of A, then it will be equal to the open surface integral, that is surface integral over divergence of curl of A dot n cap ds. So this is curl of A dot n cap ds. So this is the conversion of ds to dr. So C is traversed in the positive direction. Here what is the meaning of the positive notation? Positive means the counterclockwise direction. So whenever the contour we are taking it as a counterclockwise, we are taking the positive contour. Whenever we are taking this kind of direction, that is clockwise direction, we are taking the negative contour or the negative direction. Okay, this is, remember, this is important for you. Now we shall discuss some previous year question that has already come in CSIR net. So the first question, that A equals to yz I cap plus xz j cap plus xy k cap, then the integration, that is closed integral over A dot dl, C is along the perimeter of the rectangular area bounded by x equals to 0, x equals to A, y equals to 0, y equals to B is how much? You don't have to find out curl of C, curl closed integral over C A dot dl, because you will apply the Stokes theorem, that is curl of A. Okay, so what you have to find out, look here the Stokes theorem first, so that you just remind it that closed integral over A dot dr is equals to surface integral over curl of A dot ds. So here it is finding out, you are required to find out closed integral over A dot dr. So what you have to find, if you find out curl of A and if you take this curl of A dot ds over the surface integral, you will get the result. So first you have to find out the curl of A for this kind of question. Now curl of A finding is easy, but here I am showing you again that the curl of A you can find out by this way, that is I cap j cap k cap del del x del del y del del z, and for the x component it is yz, for the j component it is xz, for the k component it is xy. So just simple calculate the curl of the vector and then you get curl of A as 0. So here, look here, the curl of A is 0. So as the curl of A is 0, so closed integral over A dot dl is also 0. And what is the meaning of curl of A is 0 over the closed integral? It is conservative field. So it may be a question that is the field is conservative or not. Okay, look here, the same question that has repeated in June 2014, the 2013 question, and this is 2014 question with the same a vector, that is yz I cap plus zx j cap plus xy k cap, and here just a little difference with the words, that is in the plane circle in the plane defined by z equals to 1 with the center on the z axis, then the value of the closed integral a dot dl is how much, so it is 0. Okay, so same questions are repeating. So whenever you are supposed to find out the closed integral over a dot dl, you can apply the Stokes theorem and calculate the curl of that, and then you can calculate the surface integral and you will get the result. Okay, so this kind of question is very much important for your preparation. Suppose here another kind of question that you have to convert this equation, that is control in closed integral over C over the surface integral. How? The question is the work done by a force in moving a particle of mass m from a point xy to a neighboring point x plus dx comma y plus dy, and the work done is given by dw equals to 2xy dx plus x square dy. So the work done for a complete cycle around a unit circle is how much? So the work done for the complete cycle around a unit circle means you have to integration, you have to perform the integration. Okay, because the small segment has been given dw equals to 2xy dx plus x square dy. So w equals to integration over dw. So convert this closed integral, okay, so over the surface integral by applying Stokes theorem. So take, that is closed integral over 2xy dx plus x square dy as 2xy I cap plus x square j cap dot dr, because dot dr you are applying because you are writing in terms of x cap y cap. Dr is dx I cap plus dy j cap, so you can write it. Okay, so this is the method of converting this integration of, that is line integral, to the surface integral. You can now treat it as the vector, that is suppose I am taking it as f. So integration, closed integration over f dot dr, we can write it as surface integral over s curl of f dot ds. So here curl of f, that is curl of 2xy I cap plus x square j cap dot ds equals to 0, because you will just find out the curl of this quantity, you will get it as 0. So it is very simple. Okay, so this kind of question, this here, look here, there is no mentioning of the perform the closed integral or perform the line integral. Just here it is mentioned that the work done for a complete cycle around a unit circle, and that is all for the question. This is the around a complete cycle. If around the unit circle, if it is not mentioned, that you cannot apply the Stokes theorem. So Stokes theorem, this closed integral is very much important. This is another question, this has come in GATE, and this is very conceptual question. The question is the line integral integration of a to b f dot dl, where f is x by root over x square plus y square x cap plus y by root over x square plus y square y cap along the semicircular path as shown in the figure below. So what will be the line integral integration of a to b f dot dl? Okay, so here look here, for the simplification of calculation we will take the polar coordinate, not the rectangular coordinate or the Cartesian coordinate system. For the polar coordinate we can write x equals to r cos theta and y equals to r sin theta. Okay, so f dot dl, that is here change in here this is as written. So we are going, the arrow is along this side, so we are going from minus 1 0 to 1 comma 0. So the integration will be over minus 1 to 0 up to 1 0, and f dot dl can be written as x dx plus y dy divided by root over x square plus y square, because f is here, it is given as, so whenever you are taking f dot dl, you will get this one, this answer. Now put x equals to cos theta, because r is 1 here. Okay, so r is root over of x square plus y square, and x here 1, magnitude of x is 1 and magnitude of y is 0, so it will give you 1. So r is 1, so r cos theta will give you x equals to cos theta, so dx equals to minus sin theta d theta, and y equals to r sin theta, that is y equals to sin theta, dy is cos theta sin d theta. Okay, so integration, the integral will be converted to the polar coordinate form, that is, you are taking the integration over this path, and this path is here minus pi and it is 0, so you are going from minus pi to 0. Okay, so the integration of minus pi to 0 x dx, so x dx will be cos theta into minus sin theta, and dy will be y dy will be sin theta into cos theta, and d theta will be outside. Okay, so minus sin theta cos theta plus sin theta cos theta will give you 0. Okay, and root over of x square plus y square, that is 1 square plus 0 square, it will give you 1. So here, whenever you are getting this kind of contour or circular contour, you use the polar coordinate or polar vector, polar form of x, y, z. That will be interesting for you. That will be helpful for you. Okay. So this question is very much important, and the answer to the question is 0. Okay. The next question, it is very important. It has come in IIT JAM examination physical science paper. The question is, a vector field is given by f equals to alpha x cap, alpha x j cap, sorry, f equals to, shit, so f equals to alpha x j cap minus y I cap. Alpha x j cap minus y I cap for x square plus y square is less than equals to r naught square, that is region 1, and alpha r naught square x j cap minus y I cap divided by x square plus y square for x square plus y square greater than r naught square. So there are two regions, one with r naught, another with 2 r naught, and for the two region you have to understand here, for the two region there are different field. Okay, so first, the question is find the curl of the field in both the regions. Then the question is find the line integral of closed integral over f dot dl along the closed semicircle path of radius 2 r naught as shown in the figure below. So the first, the vector, there are two regions. For the first region, find out the curl of f putting this function for x square plus y square is less than equals to r naught square, that is alpha x I cap j cap minus y alpha y I cap. So del del x here I cap minus alpha y. Okay, and for the j cap it is plus alpha x, and you find it as 2 alpha k cap is the answer for the curl of the region 1, curl of f for the region 1, and curl of f for the region 2, just put the value of f for the region 2, that is alpha r naught square into minus y by x square plus y square for the I cap component, ith component or x component, and x by x square plus y square into alpha naught square for the y component. Okay, so you put here, you find out that curl of f for the region 2 is 0. Now the final question was the second question, that is closed integral over c f dot dr for the 2r. Okay, that is for the radius 2r naught. So you cannot apply directly the Stokes theorem for this 2r naught for the entire f, because you have to divide the curl of f, you have to calculate the curl of f for the two different regions, because the f has two different values for the two regions. Okay, so curl of closed integral over f dot dr, you apply the Stokes theorem, that is surface integral over curl of f dot n cap ds, and you write, you divide it two different regions, one for the region 1, another for the region 2, just because in the two regions the f field has different values. Okay, so curl of f for region 2 is 0, and curl of A for region 1 is 2 alpha k cap, which you already got, 2 alpha k cap. Now what is the sense of the rotation? This rotation is anti-clockwise. So the xy, okay, the xy, the vector will be along z. So the end cap, that is ds, the direction of ds is along k. So 2 alpha k cap dot k cap ds. So it will give you the answer, that is 2 alpha into integration over ds, the surface integral over ds. So for the full circle, what is the, this is nothing but the area of the circle, okay. For the full circle, what is the area? That is pi r naught square. But for the half circle, what is the area? That is pi r naught square divided by 2, because we are taking this term, first term, that is the radius r naught. Okay, so the surface integral will give you the value pi r naught square by 2, since this is just you are taking the half circle or semicircle. So it is alpha pi r naught square. Now suppose the sense of the uh, the integration path is anti-clockwise, like from y to x, then you have to put here the minus k cap sign, because the value you are going from, this is the xy plane, so the anti-clockwise rotation, it is positive sign, and the clockwise rotation you have to take the negative sign. Okay, so then it will become minus k cap, okay, the direction of the surface. This is a homework for you. Consider a vector a equals to minus 4y x square x cap minus 3y square y cap, and PQRS, PQRO, these are different values here for this path. So calculate the line integral A dot dl from point P to O along the path P to Q, Q to R, R to O, as shown in the figure. So you have to perform the integration, and this is A dot dl, where A is given as minus 4y x square x cap minus 3y square y cap. Okay, comment your answer. Thank you friends for watching this video. Please like this channel, subscribe to the channel, share with your friends if you find it helpful, and join our Telegram channel for regular quiz updates. You can join our test series to evaluate your performance, and the link has been given in the description box. Thank you.